So today we're going to cover graphing quadratic functions. And their graphs. Okay. So remember, a quadratic function is just a second degree polynomial. So let's say quadratic function. Is a second degree polynomial that can be written in the form. There are other forms it could be written as. Clean that up a little bit. That can be written as f of x equals ax squared plus bx plus c, where your a does not equal 0. Okay. Now your vertex is the maximum or minimum value of your quadratic function. For your quadratic function. Okay. So all quadratic functions have either a U-shape or an upside down U-shape. So let's say, for example, if your quadratic function looks like that, then your vertex would be the lowest point on that graph. So your vertex here is your minimum value. And if your graph or your parabola looks like that, then this is the highest point on the graph. So for here, this is your vertex, but this is your maximum value. Okay. No other value on the graph can be higher than that one. Or no other point on the graph can be higher than that one. Okay. So actually you can tell just by the equation or the function whether or not it's going to be facing up or opening downward. If your a, or your lead coefficient, let's just put it there. So if your a is greater than 0, or in other words, if it's positive, then your quadratic function will open upward. Bring that up a little. Okay. Which means if it opens upward, you're going to have a minimum value. But if your a is less than 0, bring this up a little bit more. So if your a is less than 0, or in other words, it's negative, didn't need that. Then it's going to open downward. And that's when your vertex is going to be a maximum value. So your maximum value, and probably put vertex there just to clear up the maximum value of what. Okay. So you don't really have to know what the graph looks like to know whether or not it opens upward or opens downward. All right. So any questions on that so far? All right. Okay, so give it, oh, someone's still writing. Okay, leave that up for a few more seconds. All right. So let's say, for example, let's say if we want to determine whether y equals negative x squared minus 14x minus 7 opens upward or downward. Okay. So really all you need to know is that lead coefficient. So y equals, remember it's ax squared plus bx plus c. Uh-oh, clean that up. So if you have y equals negative x squared minus 14x minus 7, in this case your a is equal to negative 1. So since it's less than 0, you know it's going to open downward. Instead of the function, I'll say the graph. Okay, which means it's going to look something like that. Okay, so any questions on that one? All right, so if you have one, let's say, if we wanted to determine whether y equals 9x squared plus 5x plus 33 opens upward or downward. Same thing. If you have your y equals 9x squared plus 5x plus 33, okay, you know your a is equal to 9, which means it's greater than 0. Okay, so a is greater than 0 means the graph opens upward. Okay, that a doesn't tell us much else, but tells us that much. All right, so any questions on that one? All right. Oops, so this one would kind of look like that, give or take. Oh, everyone's still writing. Oh, okay. Okay, so your formula for your vertex okay, so for f of x equals ax squared plus bx plus c, your vertex is actually equal to negative b divided by 2a, and your f of negative b divided by 2a. Okay, so in other words, this would be your x, and this is your y, as you say your y, or your f of x. Okay, and just a reminder, you can find your x-intercept by making y equal to 0 and solving for x. Kind of separate that. And your y-intercept can be found by making x equals 0 and solving for y. Okay. Now the axis of symmetry that's just the point to where on your parabola it looks like a mirror image on both sides. So it's kind of, you pretty much look at it as where it cuts it in half. And it's always the x value of your vertex. Okay. So in other words, your axis of symmetry is going to equal negative b divided by 2a. All right, so any questions on that so far? All right, let's do a couple of examples. Oh, see if anyone's still writing. I'll leave that up for a few more seconds. All right. Okay, so let's say, for example, actually, before we do the example, let's go over the steps. Steps to graphing quadratic equations or quadratic functions. Okay. So the first thing you want to do is you want to have it in quadratic form. So it's f of x is equal to ax squared plus bx plus c. Okay. In most cases, it'll already be in that form, but every once in a while, they'll change it up. Okay, and when you do that, you want to identify your a, b, and c. Okay, so you're going to need that because your next step is to find your vertex. So remember, your vertex is going to equal negative b divided by 2a. over f of negative b divided by 2a. Okay, so once we solve for x, we just plug that value right back into our function. Okay. So your third step is you want to pick at least 2 values to plug in for your x so you can graph it. Oh, 2 values of x. As I guess you could say, you can call them coordinate points or points on your graph. Okay. Now for those 2 extra points, usually it's easiest to pick your intercepts. So sometimes you can pick your x and y intercepts. That's usually the easiest way to go. Okay. Then your fourth step is plot your points from your vertex and the 2 extra points you picked, and graph. And points from step 3, then graph. Alright, so let's say, who wants to write in? Alright. Okay, so let's say, for example, we want to graph f of x equals negative 2x squared minus 8x minus 8. Okay, so the first step, it's already in the right form. Okay, so we really don't have to do the first step. Okay. So your second step, you want to find your vertex. Well, actually, with the first step, you can identify your A, B, and C. So if we go f of x equals negative 2x squared minus 8x minus 8, we know your A is equal to negative 2. Your B is equal to negative 8. And your C is equal to negative 8. Move this down just a bit. Okay. Now your second step, we know that your vertex is equal to negative b divided by 2a over f of negative b divided by 2a. Okay. So remember, this is going to be your x, and this is going to be your y of your vertex. Okay. So if we solve for our x, which is negative b divided by 2 times a, that means it's going to be negative 8 divided by 2 times negative 2, which is 8 over negative 4, which is negative 2. Okay, so we know the x of our vertex is going to equal negative 2. So we now plug that into our formula. So that means it's just going to be f of negative 2, which is going to be negative 2 times negative 2 squared minus 8 times negative 2 minus 8. Okay, so you have positive 4 times negative 2, that's negative 8. Negative 8 times negative 2 is positive 16 minus 8. So you have negative 8, and negative 8 is negative 16, plus 16 is 0. So we know our, well, I guess you can say your f of x is equal to 0 instead of y. Okay. So we know that our vertex is going to equal negative 2, 0. Okay. So we have 1 point. Now we have to find 2 other points. Okay. Okay. So to find 2 other points, we have our x-intercept, which means we make y equal to 0. Okay, so that means we have, instead of f of x, negative 2x squared minus 8x minus 8 equals 0. Which means we can factor a 2 out of all of those. And I'll put it underneath. Or really a negative 2. Might as well have that as a positive x squared. So you have x squared plus 4x plus 4 equals 0. Okay. So if we divide both sides by negative 2, that's x squared plus 4x plus 4 equals 0. Which factors out to become x plus 2 times x plus 2 equals 0. Which means x would equal negative 2. Okay? So they really just gave us our vertex over again. That's why I said you can sometimes use your x and y intercept. Okay? So since we already have that one, we'd have to pick another extra point. I mean, we can pick our y-intercept, because I'm pretty sure that will be different. Move that up a little bit. So your y-intercept is when you make x equals 0. Oh, let me put a little note next to this one. Same as vertex. So we can't use it. Okay. Now for your y-intercept, that's just y equals negative 2 times 0 squared minus 8 times 0, bless you, minus 8. Okay. So all we did was get our original function and replace all the x's with zeros. Okay. So that disappears and that disappears because they would both just become 0. That means your y is equal to negative 8. So your y-intercept is actually 0, negative 8. Okay. So we have our vertex and we have our y-intercept. So we have 2 different points. So we have to find at least one more. Yep, and we'll continue this on the next page. I'll leave that up for a few seconds. Right. So, what if we let, oh, I'm going to need to look at that. Let's say x equal -1. Doesn't really matter which value you pick. You can just pick any. I just pick -1. Okay, so that means f of -1 is going to equal -2 times -1 squared minus 8 times -1 minus 8. Okay, which means you're going to get -1 squared is 1. 1 times -2 is -2. -8 times -1 is +8 minus 8. So these two cancel out, so you end up with -2. Okay, so when x equals -1, your y is equal to -2. Okay, so we have our third point. Wasn't one of our intercepts, but it worked. Okay, so we have our 3 points. Okay, so our fourth step is we go ahead and graph. Okay, so we have our vertex, which is -2, 0. We have our y-intercept, which is, let me look on the 0, -8. Okay, now I don't need that. And we have our third random point, of -1, -2. Okay. Now, a little reason as to why I picked -1, and I'll kind of give you a hint, because we know that since the lead coefficient is negative, it's going to open downward. You have your vertex. We have our vertex at -2, 0. You want to pick an x value to the right and an x value, I guess that one's still to the right, but kind of close up, and I'll show you why the axis of symmetry is important. So if you can pick two values both on, I guess you can say, the same side of the vertex, you'll see why it works out. Okay, so if we get our graph, okay, so let's say we graph our vertex, say -1, -2. That's our -2, 0. Our y-intercept is 0, -8. So x is 0. Let me put my x and y. X is 0, y is -8. 3, 4, 5, 6, 7, 8. Okay, so this is our 0, -8. Okay, and we have -1, -2. So we have -1, -2 as our random point. Okay, so that means if we connect these, we can assume it looks something like that. Actually, that shouldn't be touching the x-axis. So that should look more like that.